hammerhead sharks. These sharks are typically found in warm coastal areas which include South Africa, Japan, Hawaii, Australia, and in the coast of the Atlantic Ocean from New Jersey to Brazil. In these areas, scalloped hammerhead sharks can also be found swimming in schools of over 700 individuals. These schools are thought to offer protection for juveniles while they are unable to protect themselves from predators. Females will also use these schools to protect themselves from males during mating, as it is typically violent and can cause the death of some individuals. After the juveniles mature and the females no longer require protection, many of the individuals are seen swimming independently of a group. Instead, the individuals will hunt or swim in pairs. One of the more interesting facts about hammerhead sharks is their ability to see 360 degrees, which comes from the shape and placement of their eyes. In this image you can see the range of vision for a few of the different hammerhead species, including the scalloped hammerhead, which is on the bottom. Hammerhead sharks can also detect changes in the environment through electrotaxis or galvanotaxis, which is the movement towards a change in the electric field or currents. All of these behaviors are influenced strongly by the environment, so what would happen if the oceans cooled by 5 degrees Celsius? Well, scalloped hammerheads are known to hunt in deeper water, which are often cooler, and when they do this there are a couple noticeable changes. The most noticeable being the individuals close their mouths and gills to reduce cold water intake. This is because with cooler body temperatures there is a loss of muscle function and visual activity, as well as a slowing of the metabolism. Another strong influence on behavior is the proximity of other individuals. While there is past research done showing scalloped hammerhead behavior in groups, there is not enough documentation to accurately determine which behaviors change when two individuals are within a proximity of each other. This led me to ask, how does shark behavior change when one scalloped hammerhead shark is alone in an area versus when it is within a small distance of another? From previous studies, it is expected to see the individual swimming on more of a tilt and with the mouth slightly more opened. If the data supports the hypothesis, then an answer can be provided to Tinbergen's question of causation or mechanism: what causes the behavior to be performed? For this study, focal sampling will be used to document one individual's behavior in both an individual setting and group setting. The following ethogram will be used, which categorizes the behaviors based on individual and group behaviors that are commonly seen. To enhance this data, all behaviors will be recorded for one individual, which will be identified as the primary subject. This prevents any bias between the individuals if one appears to be more active than the other.